In this video, I want to solve the second problem of the calculus exam that I showed last time. Last time we solved the first problem, and this time we are going to solve the second problem, second one here. So first, let me translate this problem statement. What we need to do here, we need to verify that the Lagrange theorem is applicable to the function f of x equal to arcsine of x in its domain AB, and we need to determine the Lagrange points, that is, the points C for which the theorem holds true. So let's first state what Lagrange theorem tells us. So the statement of Lagrange theorem is basically the following. So we know that the first derivative of the function f of x, which is the arcsine of x in this case, but let's be more generic, let's be more general here, f prime of x is equal to, or maybe I can call this point, instead of x, I will call it c. So it will be this point or these points. So it can be plural because there can be more than one point. And this is equal to f of b minus f of a divided by b minus a. So Lagrange's theorem tells us that there exists in some interval ab, which is the domain of the function arcsine of x, which is a function that is limited between minus pi over 2 and pi over 2. We know that there exists a point C, at least one point C, such that f prime of C is equal to this ratio. So this is basically, so if we have a function more or less like this, let's say, so this is the point, for example, this is the point, this is the x-axis, this is the point A, this is the point B, and this is the domain of the function, so there is nothing here. We know that if we take this ratio, f of b minus f of a, divided by b minus a, well, it is the slope of this line here. So I am simply connecting the 2 points f of b and f of a, these 2 points here, and we have this slope. The problem, the theorem tells us that there exists a point C such that the slope of the function is equal to the slope of this line. So for example, I can see that this point might satisfy this theorem, might comply with this theorem, because the slope here is very close to this line. And there might be another point. Actually, there will be another point somewhere here, because here we will have a similar slope, like that. We need to apply this reasoning to the function arcsine of x. We need to apply this theorem to this function arcsine of x. And it is quite easy, because the derivative f prime of x of the arcsine of x is equal to 1 over the square root of 1 minus x squared. And now we need to apply the theorem. So we need to find f prime of c equal to f of b, which is arcsine of 1, because b is equal to 1 in our case. Remember that the interval AB is the domain of the function. This is what our problem statement tells us, that AB is the domain. So B will be equal to 1 and A will be equal to minus 1. So we need to calculate arcsine of 1 minus arcsine of minus 1, and then we divide by 1 minus minus 1. So this is equal to, basically this is equal to arcsine of 1, because arcsine of minus 1, since the arcsine is an odd function, is equal to minus arcsine of 1. So we will get arcsine of 1 because we have a factor of 2 here in the denominator. And this is equal to pi over 2. This will also be equal to f prime of c. So this will be equal to 1 over the square root of 1 minus c squared. And now it's trivial because we know that the square root of 1 minus c squared is equal to 2 over pi. And therefore, from here we get 1 minus c squared equal to 4 over pi squared. And then we will get c equal to plus or minus the square root of 1 minus 4 over pi squared. Now you can see that 4 over pi squared is much less than 1 because, well, pi squared is between 9 and 10, right? So 4 over something between 9 and 10 is less than 1, not much less than 1, but it will be less than 1, and therefore this will be, so this square root exists, and this is a positive number. So we have 2 points, C, one with a plus and the other one with the minus, for which the theorem holds. So the points lie in the interval minus 1, 1, because C, the absolute value of C is less than 1. And we solved the second problem. Next time, we will solve the third one.